Hello guys, so today we're going to see about how to design a RCC bridge in our StatPro software. So let's get into our software. So after opening our software, select on new project, click on space, give the structure name as RCC bridge. So the length units will be in meters and the force will be in kilonewtons. Click on next, click on add beam, finish. So now our structure will be open. The structure wizard has been opened. So now we have to rotate this one, and now we have to draw our structure. So I'm taking a height of 8 meters. So this is span, and taking a width of 1, 2, 3, 4. So 4 meters, and again to here. On escape. Now click on this mesh. So now we have to select our diagram. So click on the translational repeat about the z-axis. So we're going to take about the 5-meter steps. So we're going to take as 3 meters. So and we are taking the steps of 5. So 5 3s are total 15 meters. Or we'll take another one. 6 3s are 18. So we're going to take 5 steps. So click on link steps, click on open base, click on OK. So here we can see our structure has been modeled. So after that, so we have to give the supports or the property whichever you want first. So I'm gonna give my supports. So go to support, click on create, click on add, and select the support and drag these 2 points. Click on assign to selected nodes and assign yes. So see, our supports has been assigned. So now we're gonna draw a mesh plates on this. We will do the surface meshing. So we can do individual for this parts, or we can do by the whole structure also. So select the quadrilateral meshing, click on OK. So click on apply. So it is apply. So again click on quadrilateral, OK, and apply. So next this one, this part, and this one. Click on quadrilateral meshing, apply, OK, apply. So our meshing part has been done. Now go to property. So click on define. So we will take the pierce as the 1 meter and the rectangular beams as we're gonna take 0.75 by 0.5 girders. It's about z-axis, and we're gonna take 0.5 and 0.5 as for the x-axis. So we take the circle, and now we will go to select beams parallel to y. Click on select assign to selected beams, assign yes. So here in 3D we can see, so our property has been assigned to it. So now we will place this heavy girders about the z-axis. So click on beams parallel to z. So now assign this, assign. So again we will see the 3D view of this. So here we can see the 3D view of our diagram. So now we have to assign this one to our x-axis. So beams parallel to x. So click on assign yes. So see, here we can see our beams are assigned and columns has been assigned. So now we will add the properties and go to thickness. So here surface thickness will give us 0.8 meters. Con add and close. So we go to assign to view, assign yes. So it won't be assigned. So we have to select the surface cursor and select this one. So click on this one, assign to view, assign yes. So save this one, so we will be able to see the data. So here we can see it has been assigned. So if we go to 3D, so here we can see it has been assigned. So here we can see that the surface or the beams are coming, so it's only not a problem. So now we're going to take the materials, click on concrete, assign to view, assign and yes. So the material has also been defined. So now we'll go to loads and definitions. First of all, we will go to our vehicle definitions. We will define what. Yes guys, so we will go to the vehicle definitions. So before that, we're going to take this type of loading. This is the wheel loading. So here you can see it's 27 kilonewtons, 27, and this is the meters. So this is the tracking wheel loads. So it's gonna take a width of 1.8 meters in between the wheels. So we're gonna take this IRC class A loadings to the axial loads. So we will define that. So for that, first of all, you have to go to vehicle definitions, click on add. So here we have to mention the width as 1.8. Now here we have to give the values. So this 27. So here we're going to say 27 and again 27 and this 27 and then distance of 1.1. So we're going to give 1.1 and if you click on tab it will come the next one. So next we have 114 at the distance of 3.2. So 114 kilonewton at the rate 3.2. So again it's saying us so now again we have to take this 114. So click on tab 114 at the rate of 1.2. So 114 at the rate 1.2 and next 68 for 44. So next click on tab 68 4.3, click on tab. So 68 4.3 and 68 3 meters. You want to take 68 3 meters and click on tab. So here is done again 68 3 68 3. So 68 3 and tab 68 and 3. So click on add. So again also we will add another one also with plus 1.8 width. So same like that, only we have to add these two types 27 27 1.1 on tab 114. So 114 3.2 114 3.2 next 114 1.2 next 68. So 1.2 68 4.3 68 sorry it has deleted now. So this when you're wrong with 1.1, click on tab, 114, so 3.2, 3.2, next 114, 1.2, next 68, 4.3, next 68, 3, 68, sorry, 68, and this one is 3, 68, and tab 3, 68, and 3. So you will see once 68, 1.3, 1.2, everything has been added. Go on add and close. So okay, so then we have to go to our load cases, click on add, select the date load, we'll give the real, add. So, and now for this we also the live load doesn't require, so we will go to our vehicle. So click on load generation, click on 100, click on add and close, click on date load, add. So now we'll go sulfate, add, close, click on sulfate, assign to assign, yes, sulfate has been assigned. Now go to generate load, click on add. So this is the type 1. So now guys, so before the loading of it, so we will go to our deck design. So for that you have to go to bridge deck. So now we have to select this one. So now go to here, you can see deck, click on create deck. Okay, so the deck is created. So now go to define roadway, click on new, go to your custom. So please deselect this one and click this as 90 and this one as 15 meters, so which is our length of our bridge. So here we're going to take the width of 3.75, so it's from the origin like 2 meters, or we're going to 3 meters from the origin. So we have to deselect all this. Now click on apply, so it will apply. Next click on copy lane left, so deselect this one. So here you can also change the dimensions. If you give 7 or you can give 8, so we will take as per the diagram 6.75, click on apply, okay, close. See, here we can see our roadway 2 lane. So now we have to go to your loading, click on influence surface generator, so it will generate the surface. So it's saying some surface are missing. So guys, we have created this lane 1. So now we are going to again go to the modeling. So now we will define the loading patterns for our vehicle. So go to load generation, click on add. Now here we can see, so our height is 8 meters. So for the pierce is 8 meters, so select the 8. So the increment of the load is 0.25 meters for the each one. So here we're going to take as 2 meters, click on add, yes, and yes. So it has added. So see, here we can see, so it has exceeded. So which we have given the values is exceeded, so it's taking like, so here we can remove this one, so that our 3 meters, delete this one, delete, close. So here we have to change this. From change, close. So now we can see that it's not moving, so we have to change these dimensions. So guys, so here we have to change this one to up to here only. click on change, close. So now we can see here the loading has been changed. For the second type also we will delete this also. So we have to place some value, then it will click on backspace, click on change, close. So now see it has been generated. So click on generate load, click on add, select the type 2. So again the increment for this will be 0.25. So for the z coordinates and y is the 8 meters. So from the x, so it's like it's from the 3, and this is 1.8, so 4.8. So again we will take our advance of 6.75 and add and close. Now see it has been added. So we will take this as okay, the x coordinate will be 2 point. Okay, it will remain like this only. So this is the first and this is the second one. So we will change the 3 meters, we can change and close. So this is the width of the vehicle, so which your vehicle is moving. So here we can see, so the every part of this, so here we can see the distance as 1.2 and this is 1.5 for this pathway, and this will be 3.75 or it will be 8. So now after we create this, so now we go to general loads and definitions. So we have defined all the loadings. So now we have to run the analysis. Click on analysis, add and close. So guys, now we will run the analysis. Click on run analysis. So it will take some time for the analysis. So let's wait. So guys, here we can see our is done with 0 errors. Now go to post processing mode, on OK and on apply. So you can see the plates, optimize your absolute. Okay, so this is the absolute. So the animations, about the deflections. So no deflection is going on. You can see your beams. So how the distance and so how this one happening. So you can see this loading, how this FY movement is kind of happening here due to the loading. So you can see the movements with the FZ. The beam stresses and the plate stresses, you can see. So after that you can see the moving loads, everything nodes onto modeling. So here you can see the loading spot, so how the loadings are going on. So we can see here. So okay guys, so now we will go to our design part. So click on concrete, click on and select IS456, select the parameters, deselect all this. Now we have to take compressive strength and yield strength. So the maximum number of sides of bars for the reinforcement, In the main one we can take whichever we require. So I'm taking these two. Wouldn't define parameters. I'm taking the synthetic grid, add, and fy is 500, add, close. We go to commands, we will take off. Now we have beam, so add beam, so add column, so add, no, that doesn't require take off and slab. We go to FC, click on assign to view, assign, yes. The fy assign to view, assign, yes. Now design beam, select our beams, parallel to X to Z. Go to node, yes. Design beam, select Y, so yes. So now we will go to analysis and print. Click on add, close, analyze, run analysis, save. Hello? हाँ हाँ भाई